All right, good afternoon, everybody. My name is Joey Glock. I'm a program manager for Microsoft Intune. So if you guys are familiar with in the Microsoft 365 umbrella, the Enterprise Mobility Suite, or EMS, one component of that, there's Azure Active Directory, there's Azure Information Protection, and then there's Microsoft Intune, which does device management. So the topic we're going to talk about today is managing devices under that umbrella of Microsoft 365. So I'm going to focus on Windows. Intune has capabilities, as some of you might know, with iOS, Android, Mac. We can manage an entire surface entirely from the cloud. So you might be familiar with managing Windows devices using SCCM, or System Center Configuration Manager. It's been a product that's been solid in the marketplace for 25 years now. And the push that Intune is bringing to manage devices in a modern way, in a continuous way, using Windows 10 and treating Windows as a service, is what we're calling modern management. And we're swinging people over from SCCM and we're moving them into Intune to manage, again, iOS, Android, mobile devices, Mac OS, and Windows OS from one console. So I'm going to walk you through kind of what a typical scenario is from a security perspective when you're managing Windows devices using Intune. And I think the way to do that is to step back and to consider the roles at play here. So one role in any IT organization is the IT administrator. So this is the person that's provisioning devices with apps, with certs, profiles, VPN, Wi-Fi, all of that stuff, getting a device provisioned and up and running. Again, this role for Windows has traditionally been living in SCCM. That has kind of been brought into Intune, and that's what I'll demonstrate. But the second role at play here from a security perspective is the security admin. In some organizations, this is the same person that's doing the provisioning as also setting the baseline for that organization. So BitLocker's got to be enabled, the PIN has to be this length, and so on. In some organizations, it's two different places. But the way we treat it as one thing, it's a pre-breach configuration and rule set to prevent security breaches, right? And so the thing that the security admin and the IT admin use as the hammer to get devices managed by Intune, which is a little different than the SCCM world, is a feature called conditional access. So this is a partnership in EMS with Azure Active Directory, cloud-based identity, and Microsoft Intune. And what it says is that for any user trying to get access on any device, Windows, iOS, Mac, or Android, they have to meet a certain bar for compliance before that access is granted. So I'm going to show you kind of what that looks like here. In Intune, we have device compliance policies. It's a policy-driven, rule-driven engine. Whereas if I create a policy here, and let's pick Windows 10 as a platform for an example, I can set a given set of settings that govern this access. So this is, let's require BitLocker, secure boot must be enabled, code integrity has to be turned on. There are device properties like minimum version of an OS, what valid operating system builds should be allowed into an ecosystem. There's system security settings like how the complexity for the PIN that governs access, whether modern credentials like Windows Hello need to be used. All of this is a cloud configuration. All of this is targeted to user identities in Azure Active Directory. Now when a user comes in, they go to Amazon, they buy a Windows machine, and they download Outlook and they just try to access email using Outlook. So this is not really the SCCM play. This is like a modern way to manage Outlook. The thing that they'll do is they'll do a request to Azure Active Directory, and instead of just giving them an access token, Azure Active Directory will make sure these rules are in place. So if this device doesn't have BitLocker turned on, if this device has a simple password, all that kind of stuff, they're not going to get access to email. And so this is all this sort of pre-breach, rule-based governing of getting devices into modern management. We're seeing a lot of adoption in the enterprise with this workflow, and conditional access is the main driver for Intune adoption. And again, it's a feature for mobile platforms, Windows, and Mac OS. But that's all IT admin, sec admin, pre-breach roles. Another role in any security ecosystem is security operations, or the SecOps admin. So this is the person that's monitoring a product on a given basis, making sure that when incidents, if and when they do occur, that those incidents are mitigated and resolved. And previously in Microsoft 365, these were across different products. And if you go through these booths, you might say, like, when do I need to go to this product to set up a given scenario like conditional access? And when do I need to go to another product to respond to incidents? So what we're releasing and what we've talked about at RSA today is one way to bridge that gap across those roles. So I'm going to flash over to a view of the Windows Defender Advanced Threat Protection. This is ATP, and this is their security center. So this is, again, everything I was talking about before was the pre-breach admin roles, setting up rules to govern access. This is after those rules are set up, there's still going to be breaches in your ecosystem. You're still going to have to monitor that. You're going to have to respond to that and mitigate against it. And our ATP console is where that happens. This is the SecOps role. So the thing that we've done, the thing that we're releasing next week is ATP risk signals for any given device. The resolution's a little messed up here. But any given device, a device can be classified as high, medium, or low risk based on a set of criteria. So if the WannaCry virus comes into your ecosystem, every device that's infected with it, ATP can scan the device at the OS layer and call that device high risk, and you can decide whether to isolate the network on that device and so on. But rather than wait for a SecOps admin to sit in a room and see this and respond to it, we're linking those roles, the SecOps admin, back to the IT admin and Sec admin roles using conditional access. So ATP can take their risk signals now and write them into Intune. And in these compliance policies, the same ones I was just showing you, Intune is able to determine for a given device threat level whether or not that device should be marked as compliant. So now in the example, WannaCry happens, the device is marked as high risk. If this rule is set up and high-risk devices are marked as non-compliant, then the device goes to high risk, and in seconds that device stops getting access to any network locations. So any corporate network locations, SharePoint, Exchange, all corporate data, that access is immediately blocked. So to give you an example of this type of attack, we have a very Microsoft screen where you're looking at the terminal here. And I'm going to click this. This is going to be a scenario where somebody gets an email up here with an attachment. The attachment has malicious code embedded into it. And somebody's going to say enable editing at the top because they want to work on it. They don't know what that means, so they say go ahead and enable this content. As soon as they do, a kernel-level exploit is leveraging a vulnerability that's giving that attacker from a remote machine elevated privilege to this machine. So in seconds, they're into system-level privilege, and now they can do whatever they want on that machine. So what they do is they move into a stealth mode, and they start remoting into other machines across an organization. So this one machine that got compromised because somebody wanted to open an attachment and enable the content has now spread to the entire ecosystem of a given organization. And this is a real-world scenario. This is actually pulled from customers that we've had. And this was just a kernel exploit that was attacked, and previously, ATP, the console, the SecOps console, raised these as results, and somebody would have to go and mitigate. In today's world, as soon as that process privilege escalation happened, ATP would pick it up, and this is our ATP console again. So again, SecOps role, dealing with this. I actually have this machine from this example here listed as a machine at risk, and it's listed as a high-risk asset. And one thing you can see is everything that we just witnessed. So dynamic code execution, it was actually blocked by Exploit Guard. So Exploit Guard did its job. That was provisioned by Intune. So Intune said, make sure Exploit Guard is turned on. It did its job, it blocked execution, but we know that this machine is still at risk, right? Injected with potentially malicious code. Here's your process privilege escalation. All of this is logged to the admin that they can see and respond. But before they even decide to respond, what ATP has already done is it has written to Intune and said that given device, which is managed by Intune, is high risk. Admin, if they defined this compliance policy in Intune, conditional access, seconds into that exploit, would block access from any other email. Everything would basically be shut down on that device before an admin has to do any response. So this is what we've been talking about in terms of the intelligence security graph, is for the first time bringing together roles like SecAdmin, IT admin, which have traditionally been isolated across our customers from SecOps, and bringing one rule base that governs access across the whole thing. And so where this conditional access would live is I've now switched to the same framework, same UI, but I'm in Azure Active Directory. I'm managing identity here. And if I scroll down, I can manage conditional access from here. And so if I created a new conditional access policy, one thing I could say is only grant access if that device is marked as compliant. So this is the tail end of that engine I just talked about. So again, in this scenario, process privilege escalation, ATP said this device is high risk. ATP wrote that into Intune, and a compliance policy was defined that says if a high-risk device ever shows up in our ecosystem, mark it as non-compliant. In AAD, you can then say, in order to get access to a given cloud app, and you can go in here and you can select from 10,000 cloud apps, Exchange, SharePoint, SAP, Dropbox, Box, all of this stuff. In order to get access to a given cloud app, these conditions must be met. So maybe the device has to be domain joined, maybe multi-factor auth has to be turned on, but the important one here is the device must be compliant, and that's what will block access from that app. So if I were to choose this and click Save and choose which apps I care about, so let's go in here and say, so here's going to be the list of the 10,000 applications, and I could say, you know what, I want to do this for Exchange. It's our most sensitive information. Select that here, click Done. I can now target this out to a set of AAD user groups. So I could say, you know what, we don't want to turn this on for all users yet, but we have a particular user group. Once this loads, rolling the dice with the demo Wi-Fi here. But we could say, yeah, you know what, we have a target demo group that we want to start with. So let's start with Adina's group. As soon as I hit select and hit save, the entire scenario I just talked about has been enabled. So now, again, if Adina was the victim of this attack that we watched up here, as soon as it happened, she'd go and she'd try to check her email and pull down more corporate information, but those floodgates have already stopped. She would be blocked, and she would go in and she'd be able to remediate that experience. So the block message in the email would say, sorry, you can't access this. She'd click on Y, and AAD would provision a message that says, ATP detected you have this given vulnerability. We're trying to go and fix it. Exploit Guard is doing its thing. Maybe in a couple of minutes you'll get your access back, but if we can't fix it, if it's something that's kind of permanent on the device, you're just going to get blocked access, call your IT admin. And before the security operations admin does anything or even notices this exploit, the person's already blocked, and the risk is just local to this machine. It can't spread across to other machines. And we've kind of choked off those access points as soon as the vulnerability was detected. So it's a lot of information. I only had about 20 minutes here, and I wanted to kind of cover a lot. But in a nutshell, what I wanted to emphasize is, again, in any of your organizations, there's no longer a product distinction between the IT admin provisioning devices or using SCCM to do so, the security admin saying, here's our security baseline, we have to have BitLocker turned on, and the SecOps admin that says, I just watched a process privilege escalation and I need to go do something. It's all chained together using the Microsoft Intelligent Security Graph, which may be something you heard a lot about, but here's a crystal clear example about how those rules are working across our products. So what I showed you here, conditional access, compliance policies, all of that is part of our E3 license SKU, so in EMS, which is again part of Microsoft 365. The ATP controls to do this process privilege attack, that's in our E5 license SKU. So ATP is an E5 product. But yeah, for the first time really in our history of our admin products, we have this net across the control plane. So that's all I have for today. Thanks for joining us today. I think you can fill out surveys afterwards. I think they said they were out of blankets or something. But thank you for joining. Take care.